So hello, I think I am live right now. Let me check if my audio, video and everything is clear. And I don't know why there is such latency on YouTube. You can see my live right now. So just wait for 5 minutes. But anyways, let's just start. Latest very let's go. Let me hand this over. So yeah, everything is working. So I don't think so that there should be some issue with that. So let us start with atomic structure. I should. I think this is better. So atomic structure starts. The chapter starts with the initial history of how electron, proton, and everything was discovered. But I just don't want to discuss it because it's kind of waste of time. But still, all the postulates and everything. So initially, the first theory that was formulated for atoms in a systematic manner, in a published manner or something like that in Royal Society of London maybe. It was Dalton's atomic theory. Okay, so it was Dalton's atomic theory. So Dalton's atomic theory said various things. Atom is smallest and indivisible. So atom is smallest and indivisible. Can we comment on that? That is true or false? So firstly, talking about smallest, it is false statement because we know that further parts of electron, proton, neutrons, further parts of atom exist such as electron, protons, neutrons, and along with electron, proton, neutrons, there are some other particles like quarks, positrons, and everything. So yes, we cannot comment on that right now, but it is it indivisible? Indivisible in what sense? In some sense, like stability. Other parts, the independent existence of smaller part of atoms in a stable manner is not possible for, like this was indivisible would have been true if radioactivity or things like fission and fusion would not have been discovered till right now, till very recently. But now, as we know, all of these have been discovered. We can say that that was a bakwas thing. So there is no point of saying that atom is smallest and indivisible. It is fundamental unit of matter. Yes, It is fundamental unit of matter. So yeah, we can say that because nothing like we don't see anything in our surrounding that is not made up of atoms or something which is made up of electrons only. Like right now, I am going to tell you about some cathode ray things, and those are not kind of matter things. Those are just uh, smaller other stuff. So yes, uh, it is the structural unit of matter. Yes, this is also kind of true, but not completely true. Then comes the further experiments that made base for yeah, Thomson's plum pudding matter. So for that, uh, initially Michael Faraday, I don't know if I am writing correct spelling or not, but Michael Faraday. Faraday is correct. I don't know about Michael. So Michael Faraday conducted an experiment about cathode rays in which he made a tube. Like, let me draw it. A tube was made, discharge ray tube it was called, and it used to look like this. And one from one side it was like this, and it's showing battery saver mode, but my computer is still too hot, so I'm not gonna put it on. Plug it in. Okay. So yes, Thomson's plum pudding model, positive, negative. So and there was a opening like this in which a pump was connected so that the pressure inside the pressure inside the cathode ray tube or discharge ray tube was made almost 10 to the power minus 4 atmospheric pressure, so that there was almost no air inside it that would provide hindrance in the path of the cathode rays. So and 10,000 volts of 10 to the power 4 volts of I will have to plug it in. 10 to the power 4 volts of potential difference was applied. And then what was a fluorescent screen was here on this side, and it was seen that there were various dots that suggested that a stream of particles is coming from uh, negatively charged side, which is cathode plate. And since it was emerging from cathode plate, it was known as it was given the name of cathode ray tube. It was given the name of cathode ray, and fluorescence fluorescence screen like this. So before LED TVs, there were TVs. TVs were like I have one in my house also. TVs were of type CRT, and CRT in the TVs was uh, abbreviation of cathode ray tube only. So there were very small cathode ray tubes that we known as that we used to think that they are small pixels or something like that. And those cathode ray tubes used to get lighted up when they got signals that yes, this program had to be shown. So yes, so discovery of electron in this. Initially, electrical nature of matter was found first. Afterwards, Faraday did an electrolysis experiment to confirm this. Then, after that, Faraday's Tony suggested that matter, uh, like matter, electricity is composed of small units known as electrons. So, final discovery was done during cathode ray. observations were, as soon as the switch of the battery was turned on, a stream of particles from cathode starts to emit out and reach at anode. Since the stream of particles came from cathode, they were known as cathode rays. And there are some properties of cathode rays. They travel in straight line, yes. They produce light when they hit fluorescent screen, as I told you. They produce mechanical effect, yes. For a mechanical effect, what was done that Faraday used a small fan and very small fan, and that had like no weight, almost no weight, and that fan did what? When the stream of particle or cathode ray passed from this cathode ray tube, that fan started revolving. So it was that like something has to push for something to revolve. So that suggested that electrons have mass and therefore they uh, show like we only till then knew that it is negatively charged because it was going towards the node. We didn't knew that it is a wave, it is a particle or something like that. So since it produced mechanical effect, we got to know that electrons are not wave, they are particles like very small particles that can produce mechanical effects. And after that, they deflected in electrical and magnetic field. So I will tell you this after that. They can penetrate through a very small sheet of aluminium, like very small, very thin sheet of aluminium. They can penetrate like so. That suggests that uh, what does that suggest? That suggests that electrons they are really small, and they can even cross through very little space available to them. Okay, so yes, that is the case. And then after that, the characteristic of cathode ray does not depend upon the gas. So we can try it with any gas: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, like any gas, but it won't show any difference in that because electron. So from where these electrons are coming? After making the pressure 10 to the power minus 4 atm, the the bare amount of there was barely some air inside it, and from that bare amount of air, whatever gas was present, the negative potential difference on this side scratched out the electron, like pushed the electron out of the atom and attracted the nucleus towards it. And when it went to the anode, it struck the anode, and the anode was enlightened, and the fluorescent screen blew. And after that, so since it does not depend upon the gas, the electron that is there in the outer shell, like electron that is revolving around an atom, does not all gases, all everything, every element in the nature has same electron in its orbit. So yes, that doesn't matter whatever gas is chosen, there will be no difference in the stream of electrons here. So yes, that was the thing. Then comes the determination of charge. This is one of my favorite parts. So this is not very important, but still it is my favorite part. So a torch-like structure was made. So uh, this is a fluorescent screen, and I am just drawing on the basis of my memory. So this is a fluorescent screen, and screen And let me use yellow color for all of this structure. And so this is okay. Let me draw a small one here and a big one here. It's positive. This is negative. 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 Yes. So yeah. And then after that, on this side one, and I am drawing this from the point of view of other side. This side one, electrically positive rod of positive charge and here a negative charge was placed, and one magnet, one electromagnet. Let how to draw the electromagnet here. I will have to watch tutorials for drawing. So an electromagnet was like that, was made. So when stream of particles, stream of electrons emerged from here, it went straight and banged this part in the fluorescent screen. This when there was no current applied to this electric. There was no positively charged rod and negatively charged rod, electrically positive and negative, and there was no magnet. Then it struck like this. When 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 uh, magnets were pulled out, when magnets were pulled in, like plugged in, if they were electromagnet plugged in, it went like this, because this is the positive side, this is the negative side, like north pole and south pole, and it went like this when there was rod. So it showed that electrons are sensitive to electric field and positive magnetic field, and this is the reason we say that they are deflected in electrical and magnetic field. Okay, so when only electric field is applied, it will strike A, B, C I have not labeled, but I written in my notes I have written. So yeah, the case of the magnetic field. In the case of the magnetic field, uh, magnetic force MS is equal to centripetal force. Like electrons are moving round and round, round and round and round and round. So electrons are getting because they're getting pushed outwards. Like if someone has like भीम की शक्ति धूम मचाए, पीछे से पूंछ पकड़ के घुमा रहा था इसको, obviously it will feel a force outwards. So magnetic force is equal to the centripetal force. So in that case, since they cancel out each other, B into E is equal to mv square upon r. So electron, this is a charge on electron, this is magnetic strength, is equal to, that becomes E by mass, charge to mass ratio becomes V by B into radius. And here we got the ratio of mass and charge. And in the case of Lorentz force, magnetic field is equal to electric field. I think I should not go in such detail because I don't know what is this. Yes, I have not myself studied this, So yeah, so leave this. So from here we did something and we got charge to mass ratio 1.7588 into 10 to the power minus 11. And after that, famous J.J. Millikan oil drop experiment was conducted. In that, few compartments were made. Like, let me draw some. भीम की शक्ति धूम मचाए सामने कोई न पाए छोटा भीम 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 something like this. So this was a box, and from here there was a pump like this, from which this looks more like a granny than a pump. So this was an oil spray in which oil was sprayed, and after that X-rays was passed out through it, so that so a very small hole was made. There was another compartment actually. So I have messed up everything. So yes, in oil drop experiment, what happened that oil was sprayed in the first compartment, and after that, in the second compartment, there were two electrically charged plates. So yes, firstly, when oil was sprayed, it was electrically neutral, and since there were charged plates, when there was a small hole made in the first compartment, so very few electron, like so very few oil drops, not drops, very few oil particles managed to escape through that small hole, and out of them, the particles who did were passed through X-rays, so that they will pass pass through X-rays, so that they will be a little more visible. And after that, uh, in the next compartment, two charge plates were made, positive and negative, and the deflection that this showed after passing through X-rays told us that what kind of electrons it is. Okay, so what kind of deflection it shows when it is under the influence of charge. So from that experiment we got to know about charge to mass ratio of an electron. So in this experiment, Millikan sprayed small drops of oil on the farm of mist between the two electrically charged plates. A single drop between the plates was observed. So for today, I think this is enough, and after some time, we will do the next stream because my computer is getting